In this video, we will prove the DeMoivre's theorem. Its statement is let z is equal to cos theta plus iota sin theta, then z raised to power n is equal to cos theta plus iota sin theta raised to power n, and it is equal to cos n theta plus iota sin n theta for all n belong to set of integers. Here we have to show that we can write cos theta plus iota sin theta raised to power n as cos n theta plus iota sin n theta. Let it be named as equation number 1. We will use the principle of mathematical induction to prove this theorem. Firstly, put n is equal to 0 in equation 1. We get cos theta plus iota sin theta raised to power 0, which is equal to 1, and we can also write as cos 0 plus iota sin 0. Since cos 0 is equal to 1 and sin 0 is equal to 0, so it will be equal to 1, and we can rewrite it as cos 0 theta plus iota sin 0 theta. Now for n is equal to 0, we have written cos theta plus iota sin theta raised to power 0 as cos 0 theta plus iota sin 0 theta. Now let's check when we put n is equal to 1 in equation 1, we get cos theta plus iota sin theta raised to power 1, which is equal to cos theta plus iota sin theta, and we can rewrite it as cos 1 theta plus iota sin 1 theta. We have written cos theta plus iota sin theta raised to power 1 in the form of cos 1 theta plus iota sin 1 theta. So we can say that this result is true for n is equal to 0 and n is equal to 1. Now suppose that this result is also true for n is equal to k, that is cos theta plus iota sin theta raised to power k is equal to cos k theta plus iota sin k theta. Let it be named as equation number 2. Now we will check it for n is equal to k plus 1, then we can write cos theta plus iota sin theta raised to power k plus 1 equal to cos theta plus iota sin theta raised to power k into cos theta plus iota sin theta. From equation 2, we can write cos theta plus iota sin theta raised to power k as cos k theta plus iota sin k theta into cos theta plus iota sin theta. Now by multiplying these two, we get cos k theta into cos theta minus sin k theta into sin theta plus iota sin k theta cos theta plus cos k theta into sin theta. From trigonometry, we know that this is the formula of cos k theta plus theta, and this is the formula of sin k theta plus theta. So we can write it as cos k theta plus theta plus iota sin k theta plus theta. And we can rewrite it as cos k plus 1 theta plus iota sin k plus 1 theta. So, given statement is true for n is equal to k plus 1, hence by principle of mathematical induction, cos theta plus iota sin theta raised to power n is equal to cos n theta plus iota sin n theta for all n belong to positive integers. We have proved this result for n is equal to 0 and for n being a positive integer. Now we will prove this result for n as negative integer. So now consider n be a negative integer say n is equal to minus m, where m belong to positive integers. Then cos theta plus iota sin theta raised to power n is equal to cos theta plus iota sin theta raised to power minus m. Since we have considered n is equal to minus m, so here we have replaced the value of n, and we can also write it as cos theta plus iota sin theta raised to power minus 1 into m, and we can rewrite it as 1 by cos theta plus iota sin theta raised to power m. It is equal to 1 by cos theta plus iota sin theta raised to power m. From 2 we can write it as 1 by cos m theta plus iota sin m theta. Now multiplying and dividing it by cos m theta minus iota sin m theta, we get 1 by cos m theta plus iota sine m theta into cos m theta minus iota sine m theta divided by cos m theta minus iota sine m theta, which is equal to cos m theta minus iota sine m theta. And in the denominator, by using the property that a square minus b square is equal to a plus b into a minus b, we can write it as cos square m theta plus sine square m theta. And from trigonometry, we know that cos square m theta plus sine square m theta is equal to 1. So we are left with cos m theta minus iota sine m theta. And also from trigonometry, we know that we can write cos m theta equal to cos minus m theta and minus sine m theta as sine minus m theta. So by using these two, we can write it as cos minus m theta plus iota sine minus m theta. And in the start, we have considered n as equal to minus m. So by replacing it, we get it as equal to cos n theta plus iota sine n theta. So we can say that given statement is true for negative integers. So this theorem is true for all n belong to set of integers.